Good morning. Welcome to another edition of Chemistry on the Fly with Mr. F. Today we're going to be talking about 5.10 chemical reactions. Now, we're starting a new section, so I figured we'd start off with a new color scheme. Hope you like it. So we're going to start off with chemical reactions. So here would be a typical chemical reaction. We have hydrogen gas in a balloon, and we have oxygen in the atmosphere, and I bring over a little flame and I create water. Well, how did that happen? Well, let's look a little more detail. So, we have hydrogen gas and oxygen gas, and we have a little explosion, and we have H2O and water. So this top part is actually called a chemical reaction. So here's our H2 plus our O2 is going to yield H2O. And again, this one's called a chemical equation. And notice there's a little asterisk on there. We'll talk about that in a little bit. So with a chemical reaction, we have H2 gas, O2 gas, hydrogen and oxygen, and we yield water. So the first two things that we have, the hydrogen gas and the oxygen on the left-hand side of the arrow, are called the reactants. The arrow itself stands for yield. And then the right-hand side are called the products. So reactants yield products. Good enough? And the reason for the asterisk, right now we have equations up on the board or up on the screen, and they are not balanced. We're going to pick up balancing in the next video. So just so you know that all of the equations in this video will not be balanced. And I'll remind us all the time that happens every time we see a new chemical equation. So here's our H2 plus O2 yielding H2O, which is water. And again, reactants yield products. And in this case, our reactants are going to be H2 and O2. And they're going to yield, after the reaction, we have H2O or water. Now, what I want you to get out of that, reactants yield products. Reactants yield products. Reactants yield products. Reactants yield products. Thank you, Patrick. I didn't think you would know that, but thanks for helping. So there are 5 types of reactions. The first one is synthesis. The second one is decomposition. The third one is combustion. And the last 2 are single replacement and then finally double replacement. We're going to pick up each one of these as we go. So we're going to start off with synthesis reactions. Now, synthesis means to combine things. We put 2 things together to make one bigger thing. So the key word for synthesis is going to be combining. We have 2 or more reactants and we're yielding one product. Now we've already seen this reaction, the H2 gas, hydrogen gas, and the oxygen gas yielding H2O, and that would be a synthesis reaction. Now, earlier we had the little explosion going on between the two as we produced water. Most of the time synthesis reactions do not have explosions in them. They're just pretty basic reactions. Although this reaction could be, and we'll talk about this in a few slides, this reaction will also be considered a combustion reaction. Now, another way we look at synthesis reactions is they are simple, yields complex. So H2, very simple molecule, O2, very simple molecule, and it yields H2O. Not a hugely complex molecule, but certainly more, actually compound, more complex though than H2 or O2 by themselves. Now again, a little reminder, our equations are not balanced. Now the next one is decomposition reactions. This one is actually the opposite of synthesis reaction. This is going to be breaking down of one reactant into 2 or more products. Now I can take our reaction, now this one looks really close to the last one, I just flip the two around where the water is the reactant and the hydrogen gas and oxygen gas are the products. And this reaction can actually happen with a little bit of electricity. And in this case, we would have complex yields simple. So water is the more complex, and the H2 gas and the O2 gas are more simple. So that's the difference between decomposition and synthesis. They're basically opposites of each other. And still, we're still not balanced. Okay, combustion reactions, these do cause explosions. And this is going to require a fuel and a free oxygen as reactants, and often yields carbon dioxide and water. So, what do I mean by free oxygen? Well, oxygen in the form of O2 gas. Okay, what do I not mean about free oxygen? Free oxygen like carbon dioxide, CO2, although there's oxygen there, the oxygen is not free to work with combustion because the oxygen is stuck to the carbon and the carbon holds it together. So that's not going to be something that is going to be free oxygen. So notice that the carbon in the middle is separating the two oxygens, so it's not able to be free. So when I say free oxygen, I'm talking about O2 as opposed to something like CO2. And there will be times when we'll have oxygen in other compounds on the reactant side. We'll see them a little bit later. So this is an example. This time with the H2 and the O2 are actually going to be our products. Our reactants, excuse me. H2 in this case would be my fuel. The O2 would be my free oxygen. And in this case, I don't produce carbon dioxide, but I do produce water. And the reason why I don't produce carbon dioxide, because my fuel doesn't have any carbon in it. Now, most of the time when we talk about combustion, we will talk about some carbon-based fuel. And let's look at a different example. This example would be methane, CH4, and notice that it has carbon in it, and free oxygen, and then it does yield carbon dioxide and water in this particular reaction. And as always, they are not balanced. And again, we'll pick up balancing next time. Now the next two reactions, the single replacement and the double replacement, I look at both of these as dances. So the first one, the single replacement, I look at this as a slow dance, where someone cuts in. It's going to have a single and a couple as reactants and a single and a couple as products. Let's look at an example. So I have carbon plus silver bromide is going to yield copper bromide plus silver. So where are my singles? So here's my copper as a single in red. Okay, where's my couple on the reactant side? I have silver as yellow and bromine as green. And then I go to the product side after the reaction. I have silver as my single, and I have my copper bromide as my couple. So notice that I have copper as a single on the reaction side, silver is the the single on the product side. And then silver was dancing with bromine, copper cut in, and then on the product side, I have copper and bromine dancing together. Again, these are still not balanced. Now, the next one is going to be a double replacement reaction. This time, I think of it more like a square dance, where we switch partners. This time, I have two couples on the reactant side and two couples on the product side. It's just that they're not dancing together. So here's another example of a double replacement. In this case, I have my double as silver and iodine, and another couple as sodium and sulfur. They're both on the reactant sides, and then we switch partners. So the silver is now dancing with the sulfur, and the sodium is now dancing with the iodine. So that is my double replacement. So again, we can see the silver in yellow was dancing with iodine. switched partners, is now dancing with sulfur. The sodium was dancing with sulfur, now switched partners, and is now dancing with the iodine. And again, these are not balanced. So if we had to review, reactants yield products. Right, Patrick? Reactants yield products! And there are 5 types of reactions. Synthesis means combining. Decomposition means to break down. Combustion, I need a fuel and a free oxygen on the reactant side. Single replacement is like a slow dance where I have a single and a couple on each side. And then double replacement is like a square dance where I have 2 couples on each side and they switch partners. So when I look at a reaction and I have to decide what kind of reaction it is, I typically go down my list and then look for the things that we have. So if there's no combining going on, it's not synthesis. If there's nothing breaking down, it's not decomposition. If there's no fuel or free oxygen on the reaction side, then it's probably not combustion. And then I start looking, do I have singles? If it is a single on each side, then it's slow dance and it's a single replacement. If it's a double on both sides or a couple on both sides, then I have a square dance where they exchange partners. So that's all I've got for today for Chemistry on the Fly. And of course, I'm Mr. F. And always have a great day.